So I left you here discussing the bottom line here, line B. And all of you agreed that it should have a slope of 1/2 because you went here to here. Oh, I should do that in red. Because you went here to here. Some of you went here to here, here to here, which is fine. It shows me you understand that it's rise over run. But I will submit to you that if I take the two furthest points from each other that you all agreed you could use and check that, you find that it is 5 over 11, which is pretty darn close to half, but not half. Everybody understand? It's kind of like, oh, sorry, Catherine.
Is it because it's not exactly on the...
Yeah, exactly. So whenever we're graphing to find slope by counting, it's always a bit of a crapshoot because you all agreed that all 1, 2, 3, 4 of those points worked. But the further you spread it out, the better the answer became. Kind of like back when we were talking in the very first unit. If you're off by 1 millimeter and you're building a house, no big deal. But if you're off by 1 millimeter and you're trying to put a probe on Mars, big deal, right? You're going to miss the entire planet by the time you've gone the millions of kilometers you need to go. Same thing here. So if you find yourself having to count slope or find slope and it's on a graph, try to pick points as far apart as possible. Everybody cool? Okay. And of course, C and D are easy. The only problem with C and D, you remember they're special. You just have to remember which is which. So which one is C, undefined or 0? Undefined, because undefined is infinite. And that is not a slope, that is a fall, right? And of course, D is 0 because you're not going anywhere. The sled's not moving unless, again, you tie your dog to it. I actually, when I had guinea pigs, and my kids went through a bit of a guinea pig phase. They were watching guinea pig videos online, and there were people that had built farms out of their living room and had little carts and things that their guinea pigs would pull around the farms. I was like, man, you people need some children, because at the very least, you people make good pets. Get it? A friend of mine says that having a kid is like having the coolest dog you've ever had that slowly learns to talk. And before I had kids, I had heard that, and I was like, oh. And then I had kids like, yeah, that's true. But you guys slowly learn to poo in the right place. Jury's out. Some people don't. Okay, so you have to prove to me you understand this. Go ahead, take 30 seconds. Draw me a triangle in which all 3 sides have a positive slope. You remember what the direction of positive slope leans? Try to draw me a triangle where they all are positive. While you were drawing this, I will just talk for a moment, of course. I said to go ahead and try some of that work I left you, because the first 3 lessons of this unit are really very closely linked together. And I have found, like I was saying yesterday, that if I do 1 a day, it kind of falls out of kids' heads. So I'm going to do the first 3 lessons of this unit yesterday and today over 2 days, so they're all kind of crammed together, and then I'll let you go and do the work, because the work is all just as crammed together in concept. What color do I feel today? Pink? This one? It's a little thick. I'll go with that one. All right. So this is doable without a Cartesian plane, but it's easier for me to show you if I have one. So there it is. Now a triangle is what? What makes up a triangle? 3 sides. So I got to have one side, yeah? Anywhere I draw a line, it's the side of a triangle, as long as it's a positive slope. Am I okay there? Okay. Now I need 3 sides, yeah? So what are my options from here? Could I do this line? Why not? It's negative slope. Could I do this line? Okay. So I can go down there. That cool? But then I got to make a triangle. Is that okay? No, why not? Because this one's negative. Okay. So that's okay. What about that? Yeah. So everybody can do it, right? You just got to think about it. Everyone's okay? Everybody knows what positive slope looks like? Would I be allowed to make a right angle triangle? Oops, sorry, not that one. Would that be okay? One of them has no slope, one of them has an infinite slope. So that's not okay. Could I do this one? Could you make an argument for that one? Assuming this guy goes from 7 straight up to 7. Would you consider that guy to be a positive slope, even though he's infinite? Sean, why not? Yeah, it's undefined. Exactly. It is neither positive nor negative, right? Because if I go here and down, then my rise was negative, wasn't it? Still over 0. Everybody cool? All right, good. Yay. Oh, okay. I thought you just made some random noise. Okay. Now, what should have happened yesterday in the last 15 minutes of class would have been, we would have put it all together right in these 4 questions. But we went over the... thank you. We went over that. So, I have a brain. It's in here. I promise. I don't know where it precisely is right now, but it's in there somewhere. So let's start putting all that together now. So the first thing we talked about was x and y intercepts. So let's put that together. Remember, to graph any line, you need at least 2 points, right? And x and a y intercept is the 2 points you need. Agreed? Okay, so let's find them. How do I find x and y intercepts? What is every single x intercept? X, 0. What is every single y-intercept? 0y. What do you see in this equation? I see x's and I see y's. So how can I use these to help me out up here? Substitute in, right? Just like we did with function notation at the end of the last unit, right? And you can see why I like to do this before I give you that function test, because it's still the subbing in, right? So we'll do the blue one first. There's an x, so 3x stays in. 0, 0, what's happening to that y? It's canceling out. Now, in lessons right now, I'm going to write it out. Do you need to? You don't need to, but if you forget, it's not going to work very well. So I'm going to write minus 2 times 0 for the sake of lessons, plus 8 equals 0. 3x plus 8 equals 0. 3x equals negative 8. X equals negative 8 thirds. Is everyone cool? Should I put this on the graph right now? No, why not? Yeah, I'm not sure about the units yet, right? I see a fraction, so I'd like to split the graph into thirds, correct? But I might not be able to do that with the y's. The y's might be too big to fit on the graph. So let's check the y's. 3 times 0, again, for lesson purposes, you can just say to yourself, oh, x is 0, I can drop it out. Minus 2y plus 8 equals 0. Negative 2y plus 8 equals 0. Negative 2y equals negative 8. Y equals 4. Now am I in a good spot? Yes, McKenna.
I don't understand how you got the 3 times 0.
X is a 0 value. It's the y-intercept. So x values are 0. So there's an x, so I put that 0 there because this is an x value. Okay? Everybody still good? All right, so now we can check this. If we're going to make the x values thirds, then where should I put my number 1? On the third one, right? So once I write that there, I have now told whoever may be marking this that all the x's are split into thirds. Everybody happy? So where is negative 8 thirds? Where do I put the dot for negative 8 thirds? To the left. How many squares? 8. 8. Now, if I'm going to keep that same scale on the y-axis, then 4 would be how many squares? 12. Can I fit 12 on there, Toya? No. So can I keep the same scale on the y-axis? No. So what do I have to do to show that the assessor knows what I am doing? I have to write 1 at the first square on the y-axis. Everybody cool? And then where do I put the dot? At 4. 1, 2, 3, 4. Does everyone see what we have done here? Now please pay very close attention. Tell me the slope of that line. Pardon me? 1/2? Okay. Anybody else? I'm not saying it's right or wrong. I just want to hear people's guesses. Arsh. I'm sorry, what? 1.5. Okay. Anybody else? Okay. Now, obviously, you know that because I've stopped and made a big deal out of it, it's not as simple as it seems, right? It's not this. 4 over 8. Right? Why? The x-axis is in thirds, right? It's still rise over run. Our rise is 4, but what's our run? It's 8 thirds, right? So rise over run is 4 divided by 8 thirds, which is 4 times 3/8, which is 12/8, which is 3/2. Is everybody cool? Brendan. Which pink line? I don't have a pink line on here. You mean this one? This one? This one? That's a 1. Okay. All right. Everyone is good? If you change the scale, you cannot count squares. You must remember values. Just like in Unit 5 when we were doing speed, right? We had to count 12 meters in 4 minutes or whatever it was for the scuba diver. Everybody remember that? Okay. That's the first thing we talked about, intercepts. Second thing, I want to graph this line. Okay? Now we are going to do this in two ways. We are going to do this algebraically. And we're going to do it first with algebraically. So, what do you see here and here? Those are x values. What do I see here and here? Those are y values. And what do I see here? An m value. Have we talked about anything that has an x, two x values, two y values, and an m value? Right. No. That only has one x value and one y value. Right. Slope equals y2 minus y1 over x2 minus x1. The change in y's divided by the change in x's. Yes? Okay. Can I fill this formula in right now? Almost. What can I put in for m? 2. Now 2 should be a rise over run. So what is it really? 2 over 1. Do I know one of my y values? Who decides which is y2? You do. Which one do you guys want to make y2? 6? Okay, so 6 minus, then what's y1? Y over. Now, if 6 was y1 or y2, what does that make 2? x2. So I write 2, then what? Minus 4 or plus 4. So, everybody is cool with that, yes? All right, so I'm just going to change that to plus 4. And, of course, we all know how to solve this because we've done our algebra from the 6th grade. Whenever you have fraction equals fraction, what do? We did a whole unit on conversions, guys. What do you do when you have fraction equals fraction? Cross multiply. It's called cross multiply. It's not really cross multiplying, but we call it that. What's 2 plus 4 is? What's 2 times 6? 12 equals 6 minus y. Now solve that with good old-fashioned algebra. 6 equals negative y. Y equals negative 6. Everybody cool?
Wait, how did you get the 12?
2 times 2 plus 4.
Oh, okay.
Is everybody good? Yeah? All right, now let's solve it graphically. Our other friend. Which of those 2 points can I put on the graph? Point A. 2, 6. 1, 2, 3, 4, 5, 6. And then, oh, damn it. I just counted the x's. 2, 1, 2, 3, 4, 5. Yeah? Everyone agrees? Point A. 2, 6. Now, what do I know about point B? I only know the x value, don't I? Which is what? Negative 4. So the other point lives somewhere on this dotted line, correct? Do I know anything else about the line that I have to put on this graph? It's got a slope of 2, correct? So that means my rise and run have to be 2 over 1, right? Should I go to the right or to the left of point A? To the left, because I have to get over to negative, right? So that means I can't go up 2 and right 1. I must go down 2 and left 1. Am I at the line yet? No. Down 2, left 1, still not at the line. Down 2, left 1, still not at the line. Down 2, left 1, still not at the line. Down 2, left 1, still not at the line. Down 2, left 1. Now I'm at the line. This point is negative 4. 1, 2, 3, 4, 5, 6. Negative 6, which is what we knew y was going to be. Is everybody good? Okay. You do it now with number 7. Solve it algebraically and then graphically. Do I care which one you do first? No. Go ahead. There's one thing here that might mess you up. I'm interested to see if it trips anybody up. What do you think that one thing is? There's a fraction in the slope, and what's weird about that fraction? It's negative. So you got to think about where that negative sign comes into play. Has everybody got a decent start on it? Okay. Hey, man.
You should never laugh at kids, but there's a kid going up the stairs way too fast.
Did he fall?
Oh, yeah, big time.
Yesterday, a kid was walking down the hall with a camera,
Yeah.
and this other kid's like, "What do you got a camera for?" And the other kid's like, "I'm taking pictures." And then he was like belligerent about it. Oh, yeah.
Did you just say that someone fell down the stairs?
Just fell up the stairs. You would never laugh at somebody who falls down the stairs. That's dangerous. But when you fall up the stairs, you're just clumsy. I do it all the time.
Or you like shatter your knee?
I do it all the time. I catch my toe on, there's a little lip on my stairs, and I catch my toe on the way up, and then it doesn't quite go as far as it should, and then it misses the next one, and then you scrape your toe, and then you fall. I hate it. One time I was carrying my laptop down the stairs going too fast, and I fell, and I actually had to roll, and I held the laptop up and landed on my feet. Nobody even saw it. I was like, damn! I wanted people to have seen that because the laptop was saved and I wasn't really hurt. It was cool. But
Yeah. Okay, well, negative 3 times negative 1 is 3, so 3 minus that.
okay, we got it? What's the answer? X equals 5.
Oh, I did.
Now, where is the only place that you might have something different than me? You might have these reversed, right? If you had these reversed, maybe yours is negative 4 minus 5 over x plus 1 equals 3 over negative 2, which would have been negative 9, x plus 1 equals 3 over negative 2. 18 equals 3x plus 3. And then you can see they're the same. Is everybody good? If you're not good... Oh, sorry, Catherine.
Can you go over, like, the cross multiplication you did?
Yes. So you should be good to here, right? Okay, and then you just revert, or you just cross them over. Negative 2 times negative 9 is 18. And 3 times x is 3x, and 3 times 1 is 3. So what you're really doing is this. Negative 9 times negative 2 equals 3 times x plus 1. Preston first. Yes. You knew this point was negative 1, 5. You knew the line had to go to y is negative 4. There's the negative 4. So you start from here, and you know your slope is negative 3 halves. So down 1, 2, 3, then I run positive 2. Down 1, 2, 3, and then I run positive 2. Down 1, 2, 3. I'm at the spot I need to be. Then I run my positive 2, and it turns out it's a 5. Ganika. Okay. Yeah, it's blue, but that's okay, because I can still answer Catherine's question.
So when you did the 3 over 2, did you automatically make the 3 negative?
You can make either one negative.
Oh, okay.
It doesn't matter. That's why I made this guy negative in the second one.
Okay.
Because it doesn't matter. Brendan.
Is graphically also to check your work?
You could use it to check your work as well. Either way. Suhani.
What if you switch the x's and the y's around?
It will still give you the same answer, Suhani. I did that. I switched the x and the y's in green here. In the first one, I made the 5 y2, and in the second one, I made the negative 4 y2. Screw you, you piece of garbage. Any questions? Good. There's 2 more to do. Do them. You can choose whichever way you want to do it. You can do graphically, you can do algebraically. I will do both algebraic versions, making both x's and y's, y1 and y2, and I will do graphically. Yes. Everybody good? Ganika.
How come we always have to go down to
Because that's the slope. Rise over run. I don't really know what you're asking me.
Thank
I didn't answer your question.
No, I realized where I was wrong.
Oh, okay. Now, I, of course, would like you to notice that it does not matter which you make x1, y1, x2, y2, as long as you don't mix up your pairings. If you make one of the y's y2, its partner has to be x2. Okay? That's the only way you can screw this up. And if you label them x1, y1, x2, y2, it's really impossible to screw this up because you don't even have to memorize this or change in y over change in x. I'm going to give it to you. You just have to be able to apply it. Okay? Any questions about number 8? Yes, Preston.
Will we get any papers that have the formulas on them for the test?
Those are the exact words that just came out of my mouth. I will give you all those formulas. And number 9, last practice. Go ahead. Number 9 discusses what Brendan asked me about earlier. Do you just use graphing to check? Sometimes you can't even do that because what happens in number 9? I go off the graph. My only option to solve number 9 graphically is to do what to my graph? The very technical math word of smallify. We would change the scale, yes? And then we could do it. But would it give us an exact answer? No, we'd be guessing, wouldn't we? Okay? Algebra always works. Is everybody good? Danica.
I don't get how you know where you dotted it. I don't understand that.
Okay. On the graph, graphs are made of points, yes? Is that a point I could put on the graph? Yes. I would go to negative 1, 2, 3, down 1, 2. Agreed?
Yeah.
Is that a point I can put on the graph?
Yeah.
No.
No, well you can put it where oh no, it can't be a point.
I can't because I don't know the y value, but I know the x value, yes? So that point lives somewhere on this line because that line is x equals 2. Somewhere on that line is where that point lives. That's why that dot is there. The dotted line is there. Okay? Okay. McKenna. 2 times negative 2 is negative 4. 2 times positive 2 is positive 4. It's distribution. Again, I have warned you guys about this numerous times. Every single thing we have done this year needs to be used in every single unit that comes after it. Always. This is not grade 6 math anymore. You don't get to do something and then not do it again for 4 years. Next year is going to be even more. Next year we'll take every single thing you have ever talked about in math even once, and you will need to do them in one question. I'm not trying to scare you, I'm just trying to warn you. Because you have been done a disservice by math education in British Columbia. And it is up to me and Mr. DeVries to fix it by the time you go to university. You've had 9 years of them doing it weird, and now all of a sudden we want you to put it all together. Is everybody good? Okay. Now, again, there's some practice work here. We're going to skip over that and go into the last iteration of slope. So please turn to 235. Yes, it's called a dripping marker. Everybody put a dot at -2, 0. And everybody put a dot at 2, 5. And then connect the line. Everybody cool? Okay. Now, put a dot at -2, -5. Oh, I should have changed colors for that. Sorry. And to +2, 0. And connect that line. Now, what have I done? I have made parallel lines because the blue line has just slid down 5. Everyone remembers this from should be grade 7, 8, 9 transformations, moving shapes around but keeping the same shape, right? So I've got a shape, it's a line, I've moved it down, it's the exact same line, yes? Which means, where will the next dot be? It will be 5 up and how far to the right? 2? 4. And where will the next dot be for the red one? 5 up and 4 to the right. So will these ever touch? No. So how do the slopes compare if lines are parallel? The slopes are the same. Now, something that is always forgotten whenever we tell you guys any fact like this is the reversal of that fact is also true. If you have parallel lines, they have the same slope. What if you have two lines that have the same slope? Then they're parallel. Does everybody understand? For some strange reason, the second half of that often gets lost in the shuffle in your brains. Everybody cool? Slopes are the same when they're parallel, and if slopes are the same, they are parallel. Everybody good? That's the easy one. Everyone's cool with that, right? Okay. On down here, we're going to need to do two things to prove this. On the left side of your graph, put a point at -8, -2, and -8, +2. And connect it. Now, you're intelligent young people. You know that that is what slope? Undefined, because it's vertical, right? Slope is also rise over run, yes? So what would the rise over run of that be? If I was pretending that you hadn't been taught that that was undefined, how would you write the rise over the run of that line? 4 over 0. Agreed? So that line is 4 over 0. Now, let's draw a yes, Brendan. Yes, indeed it could, but I did this on purpose. I made it 4 so you could see what I'm about to do. So the rise is 4. Yes, 1 over 0 is the same thing. Is everybody cool? Okay. Now, I want you to put a line at negative 10, 0 to negative 6, 0. What's that slope? 0. And as a rise over run, what is it? 0 over 4. Do those lines meet at right angles? Yes. So they are perpendicular. What do you notice about their slopes? Reciprocal. They're reciprocated. Everybody good? Everybody okay? So, that's fact one. Perpendicular slopes. Because if it happens once in math, how often does it happen? Perpendicular slopes are reciprocals. Now, on the right side of your graph, put a dot at 2, 1. And put another dot at 8. Let's go with 8, 5. That's a horrible drawing. What's its slope? Sure you do. This guy's slope? What? 2 over 3. Everybody good? Okay. This guy has a slope of 2/3. Yes? Everyone cool? Okay. So then I want you to put a dot at 0, 0, 6. Oh, no, I'm sorry, other way around. 6, 0. Idiot. Sorry, everyone. 6, 0. 2, 4, 6, 0. There we go. And 2, 6. Yep. What is that green guy's slope? It is negative, obviously. It is leaning to the left. And what is its slope? Pardon me? 3 over 2? The green guy is negative 3 over 2. Now, are those reciprocals? They are reciprocals. We have reciprocated the fraction, haven't we? So have we satisfied perpendicularity? Yes. But notice that once we are away from vertical and horizontal, to be perpendicular, they have to lean opposite ways, don't they? So that's the other half of perpendicularity. The slopes are reciprocals, but the slopes are also opposites. Does everybody see why that has to be? The vertical and horizontal one shows us why it's got to be reciprocals. And the two diagonal ones show us why it's got to be negative and positive. Everybody good? So, parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. And this comes into play when we're doing things, it's a physics thing, like reflections and stuff. Everybody's cool? Okay. See if you are. First line has a slope of 2/3. What's its perpendicular slope going to be? Negative 3/2. Line has a slope of -7. What's its perpendicular slope? 1/7. Positive. 4. What's its parallel slope? 4. -5/11. What's its perpendicular slope? 11/5. 0. What's its perpendicular slope? 1/0, which is undefined. And slope is undefined, so its perpendicular slope is 0. Is everybody good with perpendicularity? And you can see why these three lessons kind of have to be mashed together, right? Okay. Tell me if these two lines, ST and AB, are parallel, perpendicular, or neither. If they're parallel, what will happen with their slopes? They will be equal. If they're perpendicular, what will happen with their slopes? They will be opposite reciprocals. If they're neither, what will happen?
Neither of those things.
The slopes will be different completely. There will be nothing shared. Everybody got it? So how are we going to figure this out? What do we got to check? We got to check ST's slope, right? What would ST's slope be? It would be y2 minus y1 and x2 minus x1. I chose those arbitrarily. Does it matter which one I choose? Of course not. But if I write it out, is it possible to do it wrong? If you mixed up the x2 and if I made that guy x1, but if I remember the simple fact that they have to be paired, it's really difficult to do this wrong, isn't it? What's y2? -1. What's y1? 5. Over. -4 minus -1, which is +1, right? So what's -1 minus 5? -6. -4 minus -1? -3. -6 divided by -3? 2. Now let's check the other one. I'm going to reverse them this time. I'm going to make this guy y2 and this guy x2. Then make this guy y1 and this guy x1. So, y2 is what? -1 minus 1. y1, what is it? 1 over x2. 5 minus 1. -1 minus 1 is what? -2. 5 minus 1 is what? 4. -2 over +4 is Negative 1/2. Are these parallel, perpendicular, or neither? Perpendicular. Why? Because they are opposite reciprocals. Because what is 2 really? 2 over 1. Is everybody good? Okay, and the last thing we're going to do today, and then I'm going to shut up and let you work for half an hour on however much of this slope stuff you feel you need, because it's all so related, you only need to deal with the stuff that you're concerned about, right? So, I have a triangle. The vertices are there. If it's a right triangle, what will happen with one of those corners? It will be at 90 degrees, which means they will be perpendicular, right? So what will happen with the slopes? 2 of them will be opposite reciprocals. How many slopes do I need to check? I need to check 2, but which 2? You don't know, unless you do what? Okay, you could check them all, but then I would have to do 6 sets of slope, right? What if I did this? There's A. There's B. There's C. I just sketched it. I didn't get out a ruler. What of those corners do you feel is the only possibility of a 90 degree? There. So do you need to check all the corners? No, you only need to check one. So I need to check that slope versus that slope. How do I check the yellow slope? What 2 points am I using? I'm using A and C. If I write it out, can I do it wrong? Somebody say a number, 2 or 1. 2. Okay? So I'm going to make this guy Y2. What does that make this guy? What does that make this guy? Or sorry, this guy. X1. What does that make this guy? Y1. Check the yellow slope. What is it? 1 minus 4 over negative 3 minus 3. What's 1 minus 4? And what's negative 3 minus 3? Negative 3 over negative 6 is positive 1/2. Is everybody happy? If this is perpendicular, then what must this slope be? Negative 2 over 1. Let's check. For the green one, I've already got an x2 I've already got an x1 and a y1 written here, yes? So I'm going to keep that so I don't screw it up. And I'm going to make this guy x what? X2. And I'm going to make this guy what? Y2. And then I'm going to do my math. Negative 2 minus 4 over 6 minus 3. What's negative 2 minus 4? He waited patiently. Negative 6. What's 6 minus 3? What's 6 divided by 3? Negative 2. Are they perpendicular? That's a 90 degree, so this is a right triangle. Did I need to do a perfect graph? I sketched it, and it allowed me to see. Right? Now, would it have worked if I had done my graph this way? 1, 2, 3, 4, 5, 6. Why not? That's a sketched graph. but they're totally uneven. It's not even the beginning of close, right? But notice, even just estimating but keeping them about the same, I was able to cut down on my work by 67%. Could I have checked all three corners? Yeah. But why would I? When a 2-second graph cut down on my work by 67%. Everybody cool? Okay. I'm done for everything to do with slope. You have 3 pieces of practice you could do on slope right now. Okay? You choose. Do as much or as little from the 3 textbook pages that you have there. Oh, damn it. I forgot the next page. Yeah, go ahead.
Oh, are you going to teach it?
Yeah, I guess I'd better. It literally takes 2 seconds. Can you wait? Okay. Sorry, ladies and gentlemen, I forgot about page 237. If they're parallel, what do I know about A, B, and C, D? They're the same. So y2 minus y1 over x2 minus x1 would have to equal the same thing, right? Which of those can I fill in? Can I fill in the AB or the CD right now? I can totally fill in AB, right? Once I fill in AB, I can use these letters to work out CD, right? Everybody cool? We're not going to do it. You're going to do that because I don't think you need to practice subbing in, do you? Okay, that's cool. You're going to figure this out. Then I'll show you the answer in 2 seconds. What if they're perpendicular? What would happen to AB's slope which we can find? What would we do to this slope down here? I would reciprocate it. So instead of y2 over x1, because I would flip it and opposite it. So AB down here would not be y2. What would it be? x2 minus x1 over y2 minus y1 with a negative in front. And then I could do the same work. Would I change CD? No, because CD was what we didn't know, right? So CD we would leave the same. And I can't remember what color I wrote CD in, red. CD would stay the same. Does everybody understand why? Could I have flipped the CD side and left the AB side? Could I have done that? Yeah. Could I have taken this answer that I know and just flipped the answer instead of writing x2, x1? Could I have done that? Yes. Well, only at the perpendicular one. I couldn't do it up above. Is everybody cool? Does any one of those methods work better than any of the other ones? No, you're going to get the same answer. I'm trying to show you all the ways you can think about perpendicularity. Everybody good? So all you would do here is fill in the numbers. Where do you get those numbers? From the question. Okay? You go, try it out. Let's see what happens. So I've done the parallel one. Has anybody else? Has anybody else finished the parallel one? When you finish the parallel one, you're more than welcome to keep going, but I would recommend stopping for a second, just looking at what I'm about to do. But finish the parallel one, and then somebody offer me an answer. Okay, who has an answer for me? He waited patiently. Selena. 3/4? I could see why you have 3/4. The 4 is correct. Arsh. 13/4 is correct. And the mistake you made, Selena, is that +8. I assume when you brought it over, you subtracted it. Is everybody cool? That's the one you knew, 5/4. Then you just cross multiplied. Everybody good? Now, since I already know this guy, and I know I want them to be perpendicular, I could just flip this guy now and make him -4/5 and keep this the same, couldn't I? So this would still be a minus 2/1. And then the work would be -4 equaled 5a minus 10. Multiply. Add 10 to this side. 6 equals 5a, and a equals 6/5. Does everybody see why I was able to do this? And does everybody see that the only thing it does for us is save us work? I could have flipped this and just brought this down to here, right? And it would have been... that would have looked way better if it had actually worked. And it would have been... reversed, right? And then I would have had the 4 up there and the 5 down there with the negative out in front. Preston.
I don't get why you have the reciprocal of like the formula. I don't get we have equals y squared minus y1. And like I don't get why that's
What part are you speaking of, Preston?
whereas on D it says y squared minus y1. Well, yeah, right.
Because that is the CD slope that I still have to find. Slope is always that. So up here, there it was. I needed it there. But now I'm looking perpendicular. The CD slope isn't changing. But I need it to be perpendicular, so I had to change the AB slope. Okay? And then I got 6/5. Now, some of you will be saying, oh, Mr. Myers, those are fractions. Don't fractions exist on the Cartesian plane? Couldn't I put a dot at 13/4? Yeah, because it's only 4 1/4, right? Couldn't I put a dot at 6/5? Yeah, it's 1 1/5 or 1.2. We can put those on graphs. So it's okay to have fractions as these answers. Everybody good? Great. Now go You practice as much or as little as you see fit about slope. Remember, we are having our functions test on Thursday. Hey, sorry about that, everyone. I had to secure some computers for the last block. Yes, I do have scissors. Well, normally I have scissors. Oh. All right.
whole group